We're watching grainy footage from 1963 that should be physically impossible. A massive C-130, an 85,000-pound cargo plane with a wingspan longer than the Wright brothers' entire first flight, is approaching an aircraft carrier at sea, not flying over it, landing on it. Lieutenant James H. Flatley III guides the four-engine beast toward the USS Forrestal, a ship designed for nimble fighter jets, not lumbering transport aircraft. The tailhook isn't even down, because there isn't one. This plane was never meant to land on ships. It touches down, rolls exactly 270 feet, and stops. No catapult, no arresting cable. Just raw skill, and a plane so versatile, it casually rewrites the rules of what aircraft can do. Flatley will repeat this lunacy 29 times over the next few weeks, then take off from the carrier deck 21 times, proving that the C-130 could potentially resupply carriers at sea without ever needing a port. The Navy ultimately decided not to pursue it operationally, but the message was clear. This aircraft doesn't care about your limitations. That 1963 stunt wasn't a fluke. It was a preview of what would become aviation's most improbable success story. The Lockheed C130 Hercules has now been in continuous production for over 70 years, longer than any military aircraft in history, serving in more than 70 countries, flying in every conceivable environment from Antarctic ice sheets to Middle Eastern deserts, performing missions its designers never imagined, and doing it all with one of the lowest accident rates in military aviation. It has dropped paratroopers behind enemy lines, evacuated casualties under fire, fought wildfires, hunted hurricanes, operated as a gunship raining down precision fire, refueled helicopters mid-flight, and delivered bombs so massive they wouldn't fit in actual bombers. And it does all this while looking like a design student's first sketch. A blunt, ungainly tube with 4 propellers that screams brute utility over elegance. Yet somehow, this unassuming workhorse became the most successful military transport aircraft ever built, and the reasons why reveal truths about military aviation that most people never consider. The C-130's origin story begins not with innovation, but with desperation. When American forces deployed to Korea in 1950, they discovered their transport fleet was catastrophically inadequate. The Douglas C-47, a military version of the legendary DC-3, was too small and too slow. The Fairchild C-119 flying boxcar had the cargo capacity, but needed long paved runways that barely existed in Korea's mountainous terrain. The Douglas C-124 Globemaster could haul enormous loads, but was equally runway dependent and far too large for tactical operations. What emerged from Korea's brutal lessons was a clear requirement. The military needed a single aircraft that could land on short, rough airstrips, carry substantial cargo, operate in any climate, fly at tactically useful speeds, and survive in contested environments. It needed to replace multiple specialized aircraft with one adaptable platform. This was, to say the least, not a modest request. In 1951, the United States Air Force issued a requirement for what they called a medium transport aircraft. It needed to carry 92 troops, or 64 paratroopers, or 74 litter patients. It needed to operate from unprepared surfaces. It needed a rear loading ramp. It needed to fly high enough to clear mountains and low enough to avoid radar. And critically, it needed to be powered by turboprop engines, a relatively new technology that offered jet-like speed and reliability with better fuel efficiency and short field performance than pure jets. Lockheed's response was the YC-130, which first flew on the 23rd of August 1954 and immediately demonstrated that sometimes ugly and practical beats are sleek and limited. The Air Force ordered it into production, and the first operational C-130A entered service in December 1956. What made the Hercules revolutionary wasn't any single radical technology. It was the integration of multiple design features into one coherent package. The high mounted wing allowed the cargo compartment to sit close to the ground, making loading easier. The four Allison T56 turboprop engines provided enormous power and redundancy. Lose one engine, keep flying. Lose two on the same side, still flyable. The landing gear was specifically designed to handle unprepared surfaces, with multiple wheels spreading weight across soft ground. The cargo ramp could open in flight for parachute drops or air-deployed equipment. The entire fuselage was pressurizable, meaning it could comfortably fly at high altitudes where weather and threats were less dangerous. And critically, the wing was positioned high enough that the propellers cleared ground obstacles, preventing damage during operations on rough fields. The cargo compartment itself became the aircraft's defining feature. At approximately 41 feet long, 9 feet high, and 10 feet wide, it created a pressurized box that could swallow an astonishing variety of cargo. You could fit 2 small trucks inside. You could fit artillery pieces. You could reconfigure it in hours for different missions, installing palletized seating for troops, litter racks for medical evacuation, or leaving it completely empty for bulk cargo. The rear ramp allowed straight-in loading, eliminating the awkward side door limitations of earlier transports. And because the ramp could open in flight, cargo could be extracted by parachute, dropped by gravity, or pushed out using specialized extraction systems. This versatility meant a single C-130 could be flying paratroopers one day and hauling fuel bladders the next. But here's what truly separated the Hercules from its predecessors. Lockheed and the Air Force never stopped improving it. Most successful aircraft get produced, enter service, maybe receive minor upgrades, then fade into obsolescence as newer designs replace them. The C-130 took the opposite path. Every few years, a new variant appeared with better engines, improved avionics, enhanced cargo handling, or mission-specific modifications. The C-130A gave way to the C-130B, then the C-130E, then the C-130H, each iteration refining the design without abandoning the core airframe. By the 1990s, the C-130J Super Hercules represented a nearly complete technological overhaul, with new engines, a digital cockpit, and performance improvements across the board. Yet it still looked unmistakably like the aircraft that first flew in 1954. This continuous evolution allowed the C-130 to become far more than a simple cargo hauler. The AC-130, a gunship variant, turned the Hercules into a devastating ground attack platform, mounting cannons and howitzers that could orbit a battlefield for hours, delivering precision fire. The MC-130 Special Operations variants added terrain-following radar, aerial refueling capability, and specialized navigation systems for covert infiltration missions. The HC-130 became the Coast Guard's primary search and rescue aircraft, equipped with advanced sensors and capable of dropping rescue equipment to survivors at sea. The KC-130 provided aerial refueling for Marine Corps helicopters and tactical aircraft. The WC-130 flew directly into hurricanes, collecting meteorological data that no satellite could provide. And the civilian L-100 variant served commercial operators, hauling cargo in remote regions where infrastructure barely existed. One variant deserves particular attention for sheer audacity: the MC-130E Combat Talon. It featured a Fulton surface-to-air recovery system, essentially a giant airborne skyhook. Personnel or equipment on the ground would attach themselves to a balloon-lofted cable, and the MC-130 would fly overhead, snag the cable with a specialized yoke, and winch the person or package aboard while flying at over 100 knots. This sounds like science fiction. It was operational reality, used for covert extractions where landing was impossible or too dangerous. Imagine being plucked off a mountainside by an aircraft that never touches down. That's C-130 versatility taken to its logical extreme. The aircraft's performance specs tell only part of the story. Yes, it can carry 45,000 pounds of cargo. Yes, it has a maximum gross weight of 155,000 pounds, or 175,000 pounds in wartime overload conditions. Yes, it can operate from runways as short as 3,000 feet and land on dirt, gravel, or even ice using specialized ski landing gear. But numbers don't capture what it feels like to watch a C-130 perform a tactical assault landing, descending at angles that seem aerodynamically impossible, flaring hard at the last second, slamming onto a dirt strip, reversing props immediately to brake in a fraction of the distance civilian jets require, then offloading a company of soldiers in under 3 minutes before taking off again into hostile airspace. The C-130 operates routinely in environments that would ground almost any other aircraft. The Antarctic research missions exemplify this capability. Every year, C-130s fitted with skis land on the ice sheet at research stations where traditional runways don't exist. Surface conditions are unpredictable. Temperatures plunge to minus 40 degrees or colder. High altitude and thin air reduce engine performance. GPS and navigation aids are unreliable near the poles. Weather changes without warning. Yet the C-130 delivers fuel, equipment, food, and personnel to these stations reliably, because the alternative is leaving them unsupplied for months. No other aircraft combines the range, cargo capacity, and rough field capability to do this job. The C-130 doesn't just enable Antarctic research. In many cases, it makes it possible at all. The variants demonstrate the airframe's flexibility in ways its designers never anticipated. The original C-130 was built to carry cargo, not rain destruction on ground targets. Yet by the Vietnam War, the Air Force had recognized that a large, stable platform with long endurance could orbit above a battlefield and provide close air support that faster jets couldn't match. The AC-1000 mounts a 105mm howitzer, 40mm cannon, and a 25mm Gatling gun firing from the left side of the aircraft, along with advanced sensors including infrared and low-light television. It circles the target, bringing guns to bear continuously, correcting fire in real time, and maintaining station for hours. This loiter capability became invaluable in Iraq and Afghanistan, where troops on the ground needed persistent overhead support. Fast jets arrive, drop ordnance, and leave. The AC-130 arrives and stays. Part of the C-130's endurance comes from mission planning, but much comes from structural integrity. The airframe was built tough and maintained carefully. A key concern for any long-lived aircraft is fatigue. Every flight cycle stresses the structure. Every landing pounds the landing gear and wing attach points. Every maneuver loads the wing spars. Over time, microscopic cracks develop, metal fatigues, and structural failure becomes possible. For the C-130, the center wing box, the structure connecting the wings to the fuselage, is the critical fatigue component. It was originally designed for 45,000 flight hours under civilian equivalent conditions. But military flying is far more severe. Low altitude operations increase turbulence loads. Short field landings slam the gear. High G maneuvers in tactical situations stress the wings. So the Air Force developed a severity factor that translates flight hours into equivalent fatigue hours based on mission profile. For C-130E models, some of which were built in the early 60s, fatigue became a genuine concern by the 2000s. Average flight times approached 20,000 hours. The center wing box was approaching its design limit. Corrosion compounded the problem, particularly for aircraft that operated in coastal or humid environments, where salt and moisture degraded aluminum structures. The solution involved aggressive inspection programs, selective repairs replacing damaged components, and in some cases, complete center wing box replacements under a service life extension program. These interventions allowed aging C-130s to continue flying safely decades beyond their original planned retirement. And even as older models approached end of life, new C-130J Super Hercules entered service, ensuring the platform's continuity. By any measure, 70+ years of continuous production is staggering. For context, the Boeing B-52 bomber has served even longer, but stopped production in 1962. The C-130 never stopped. Lockheed Martin still builds them today, delivering aircraft to customers worldwide because no replacement has emerged that matches its combination of capability, reliability, and cost. Newer aircraft designs exist. The Airbus A400M offers greater cargo capacity and speed. The Embraer KC-390 provides jet performance. But both cost significantly more to buy and operate, and neither has proven as adaptable or as trusted in operational environments. The C-130 persists not through inertia, but through continued relevance. More than 2,500 C-130s have been built, serving over 70 nations on every continent. They've flown in every major conflict since Vietnam. They've delivered humanitarian aid following earthquakes, tsunamis, hurricanes, and famines. They've conducted medical evacuations under fire, saving countless lives by getting wounded personnel to surgical care within the golden hour. They've inserted special operations forces into denied territory and extracted them against impossible odds. They've supported scientific research in the most extreme environments on Earth. And they've done all this with an accident rate lower than most military aircraft, a testament to robust design and rigorous maintenance. The C-130's legacy isn't just mechanical, it's cultural. For soldiers, seeing a Hercules overhead means resupply is coming, reinforcements are arriving, or evacuation is possible. For disaster victims, it means help has arrived. For remote communities, it means connection to the outside world. The aircraft has become synonymous with reliability in environments where failure isn't an option. It's the plane that always shows up, regardless of weather, terrain, or threat, and delivers what's needed when it's needed. So why has the C-130 succeeded where so many others failed? Because it was designed from the beginning as a tool, not a showpiece. Because Lockheed and the Air Force continually invested in making it better, rather than declaring victory and moving on. Because its versatility allowed it to fill roles nobody predicted. Because its ruggedness made it survivable in conditions that destroyed more fragile aircraft. And because ultimately, it does the job. Not elegantly, not quietly, but reliably, repeatedly, and without drama. The C-130 Hercules isn't the fastest military transport. It isn't the largest or the most technologically advanced, but it might be the most successful. Because success in military aviation isn't measured by speed records or payload maximums. It's measured by missions accomplished, lives saved, objectives achieved, and years of service without becoming obsolete. By that standard, the Hercules stands alone. 70 years in production, 70 nations operate it, countless variants adapting it to missions its creators never imagined. And still flying, still evolving, still proving that sometimes the best solution isn't the most sophisticated one. Sometimes it's just the one that works every single time, no matter what you ask of it.